Welcome to the New Jersey Department of Education's first technical assistance webinar around artificial intelligence, or AI. By the end of this webinar, you should be able to understand the history of the evolution of technology in education, understand foundational artificial intelligence, or AI, terms and concepts, describe how AI is currently used in the education space and how it may be utilized moving forward, reflect on high-level discussion questions regarding AI in education to consider at the local education agency leadership and classroom educator levels, and access helpful resources around AI. Throughout history, we have observed advancements in technology challenge the status quo in education. The following slide highlights some of these technological evolutions that have transformed the way we engage with information. Going back in time to the 5th century before Common Era, or BCE, Socrates famously warned against writing because it would, quote, create forgetfulness in the learners' souls because they will not use their memories, end quote. Writing was one of the original technological evolutions in education, and while it seems commonplace today, it was not well received by all. If we fast forward to 1941, American pediatrician Mary Preston concluded children were severely addicted to radio and movie crime dramas, having given themselves over to a habit-forming practice very difficult to overcome, no matter how the after effects are dreaded. In the 1980s, there was a backlash to students using calculators in math classes, and they were banned from use. It was imagined that Wikipedia and the internet were going to replace teachers in the 1990s and 2000s. Which brings us to November of 2022, when ChatGPT 3.5 was publicly released by OpenAI. With this release, the floodgates of panic opened once again, and a slew of articles and op-eds have continuously come out about how ChatGPT, especially how the technology, impacts education. Given the subsequent extensive media coverage of AI, it is important to ground ourselves in an accurate understanding of what AI is and what it can currently do, as well as its current limitations. Additionally, it is important to recognize that this technology is continually evolving, which requires us to evaluate our understanding and perceptions of the use of AI systems in education. History shows us that each time a new technology was introduced to society, education adapted after a period of initial panic, and the benefits of the technology became better understood and embraced in the classroom. With the public availability of ChatGPT and similar systems, and their integration into various technologies within the education space, it is necessary to shift our discourse from panic to agency. Discussion should not be about whether there is a need to ban AI systems such as ChatGPT in the classroom, harkening back to the days of banning calculators, which clearly did not work. Instead, this understanding necessitates a shift in the conversation to how we must prepare our educators and students with the necessary skills to participate in a society where AI is present, both as a powerful resource and as a potential challenge. We will now level set and provide an overview of foundational terms and concepts regarding AI, what it is and what it is not. This slide shows some of the areas in which AI systems are already embedded. As you can see, AI is already a part of our daily lives, and we need to be informed and critical users of the technology. If your car used lane assist technology on your commute today, you used AI. If you asked Siri or Alexa to create a reminder to pick up something from the grocery store, you used AI. If your email or text client suggested text to finish your message, that was AI. Like all technologies, AI is a tool that can be used for positive and negative uses. That part is up to us as the users. The experience we have with AI systems will be what we make of it. So how is AI defined? AI, or artificial intelligence, refers to the development of computer systems that can perform tasks that typically require human intelligence, such as recognizing patterns, making decisions, and learning from experience. In other words, AI involves training computers to use human-generated data to respond to user prompts using an algorithm that models human intelligence. As noted earlier, we interact with AI systems in many ways, from chatbots that answer customer inquiries to self-driving cars that navigate roads autonomously. It is important to note that there are currently no AI systems that match human intelligence. While popular AI systems such as ChatGPT seem like they can think for themselves, and the media coverage hypes their abilities as so, they cannot. When referring to AI, data are units of information about people or objects that are used by AI systems. Data is generated by humans in their work or other contexts in their past. Training data refers to data that has been labeled or coded and is used to teach AI models or machine learning algorithms to make the most appropriate decisions to the best of its abilities. For example, in an AI system for a self-driving car, the training data will include images and videos labeled to identify cars versus street signs versus people. If you have ever been asked to confirm you are not a robot on an online forum and had to identify the images with stoplights, you are incidentally helping to train AI by labeling the training data that may be fed to an AI algorithm for autonomous cars. The next term to know, machine learning, refers to a type of artificial intelligence that involves training algorithms to make predictions or decisions based on data sets. In machine learning, algorithms are trained on large data sets to identify patterns and make predictions or decisions based on new data. We come across many machine learning systems in our everyday lives, including things like personalized recommendations from systems like Netflix and Spotify, and our use of voice assistants such as Siri and Alexa, and even in our email programs that filter out spam messages. These all use large data sets to make specific predictions. The image on this slide shows some of the data points collected by Netflix to feed into their machine learning algorithms that provide personalized recommendations to users. For a popular example, let's use The Crown, a show about Queen Elizabeth II's reign. If you watch the show all the way through, your profile data would be broken down into categories based on the show. Your profile data may reflect that you preferred strong female leads, period dramas, or shows for Anglophiles. Recommendations may include other Netflix shows such as Bridgerton, Broadchurch, or The Great British Bake Off. These recommendations are predictions made from the thousands of data points that Netflix has from profiles with data that is similar to yours. The next term we'll review is deep learning, which is a type of machine learning that involves training artificial neural network algorithms to make predictions or decisions based on data in real time. Deep learning algorithms are neural networks that are modeled after the human brain. For example, a human brain contains millions of interconnected neurons that work together to learn and process information. Similarly, deep learning neural networks, or artificial neural networks, are made of many layers of artificial neurons that work together inside the computer. The neural network is trained on large data sets to identify complex patterns and relationships in the data in real time. Artificial neurons are software modules called nodes, which use mathematical calculations to process data. Artificial neural networks are deep learning algorithms that use these nodes to solve complex problems. Deep learning systems are embedded into areas such as self-driving cars, where the algorithms are used to detect objects on the road and make decisions in real time about steering and braking, and medical diagnosis applications such as identifying cancerous cells in medical images and predicting patient outcomes based on medical data, and in gaming, where your opponent is an AI trained to make moves against you, like in online chess. So now you know what AI, machine learning, and deep learning are and how they can be defined, but how are they related to each other? This image illustrates the relationship between the three. AI is the overarching umbrella. Machine learning is a subset of artificial intelligence, while deep learning is a subset of machine learning. Machine learning can train on smaller data sets, while deep learning requires greater amounts of data. Deep learning incrementally improves itself via its environment and by learning from past mistakes, while machine learning requires human intervention to learn and correct itself. If you are interested in learning more about these foundational concepts of AI, training data, machine learning, and deep learning, Code.org has released a series of introductory videos linked on the resources webpage that will be provided at the end of this webinar called How AI Works. The videos can be found on Code.org's AI 101 webpage. These videos can be used to learn more about AI or to introduce these AI concepts to high school level students. Now, moving on from foundational terminology, let's talk about how AI systems are classified. For the purpose of this webinar, AI systems can be classified into two categories. The first, weak or narrow AI, is a type of AI system that is designed to perform very specific tasks or problems. Weak AI systems include virtual assistants such as Siri, Alexa, and Google Assistant, wherein their functions are limited to performing very targeted tasks such as setting reminders, playing music, or answering questions. Image recognition software is another example of a weak AI, where it is limited to focusing only on recognizing specific images. The other classification, strong AI, also referred to as artificial general intelligence or general AI, is a type of theoretical AI system that would have intelligence and decision-making skills equal to humans. It would have a self-aware consciousness that can solve problems, learn, plan, and adapt independently. When you're thinking of the Terminator, Westworld, or WALL-E, these would be considered general AI. But just as these only exist in film and TV, there are currently no AI systems that can match human intelligence. However, there are some instances of strong AI in the form of research projects or hypothetical scenarios. A few examples of general AI systems that are currently limited to research projects include Google's DeepMind, which is a research organization focused on building advanced AI systems and has made significant breakthroughs in areas such as game playing, natural language processing, and robotics, and Hanson Robotics' Sophia, which is a humanoid robot that has been designed to interact with humans, recognize faces and emotions, and hold conversations. It is important to note that artificial general intelligence, or AGI, is not the same as generative AI. Generative AI is a type of narrow or weak AI system that can generate new content, such as text or images, in response to a prompt. AI chatbots such as OpenAI's ChatGPT and Google's Gemini, GitHub's programming AI system Copilot, and art creator Midjourney are all examples of generative AI systems. OpenAI's release of ChatGPT in November 2022 increased awareness of and interest in generative AI built on large language models like ChatGPT and Google Gemini. These tools can answer questions, complete written tasks, and respond to prompts in a human-like way. Other forms of generative AI can produce audio, code, images, video, and simulations. This technology is not new and can already be found in everyday contexts like online chatbots and predictive text. Generative AI tools are good at quickly analyzing, structuring, and writing text or turning text prompts into audio, video, and images. However, the content they produce is not always accurate or appropriate as it has limited regard for truth and can output biased information. Generative AI tools can make certain written tasks quicker and easier, but cannot replace the judgment and deep subject knowledge of a human expert. Therefore, it is more important than ever that our education system ensures students acquire knowledge, proficiency, and intellectual capability. Here are some examples of AI systems you can access and share with students to demonstrate how AI works, or just to learn more for yourself. These are free to use, although some may require registration. QuickDraw is an application developed by Google that recognizes your drawings using AI. QuickDraw also provides the full datasets used by the AI algorithm, which is a powerful example of how training data is used for AI systems. These datasets can be explored at quickdraw.withgoogle.com/data. With Teachable Machine, another AI project by Google, use the camera or microphone on your device to train a machine through AI to see or hear something and predict what it is. This is a good application to use as an introduction to machine learning. Stable Diffusion is a text-to-image generator that creates photorealistic images given any text prompt. You can use Stable Diffusion's prompt search engine to explore millions of AI-generated images created with individual and unique prompts. ChatGPT is a chatbot that generates text in response to user-created prompts in a conversational format. ChatGPT has a free version that can be accessed with registration, version 3.5. This version is only trained on information up to 2021, so it cannot provide information from after 2021. Now let's take the background knowledge we've obtained so far and pivot to the topic of AI in education. AI is expected to have a transformative impact on the future of education globally. Therefore, we are presented with a pressing need for updated curriculum standards, courses, tools, and assessments to prepare students safely and equitably for a future with AI. The data used to train AI algorithms is an artifact of the human experience. Therefore, it reflects the human experience and includes the strengths and weaknesses of human beings. One of the major concerns around AI systems is how human biases are reflected in data used to train the algorithms. While work is being done to try to mitigate the impacts of human biases on AI systems, it is important to be mindful of it as we consider the uses of AI systems in education. Our students will be living and working with AI throughout their lives. It may affect almost every major facet of their lives and futures, as illustrated on this slide. Educators and students will require new skills to identify and navigate the use of these systems. Educators need to prepare students for changing workplaces, including teaching them how to use emerging technologies, such as generative AI, safely and appropriately. At different stages of education, this may include understanding the limitations, reliability, and potential biases of AI systems, how information on the internet is organized and categorized, and online safety to protect against harmful or misleading content. It may come as a surprise to some, but AI systems are already embedded and used in the education space, as you can see based on the list of examples on this slide. Popular education applications, such as Grammarly, Turnitin, Duolingo, and PowerSchool, all have AI systems ingrained within them. With the rise of ChatGPT and similar generative AI systems, there has been an influx of AI detection tools that claim to be able to flag AI-generated text with high precision. Due diligence should be exercised when working with AI detection tools to evaluate potential academic integrity violations, and additional layers of review of student work should be completed. AI systems in schools tend to fall into three categories. The first category is student-facing, in which the AI system is used by students to learn subject matter and can respond to an individual student's needs, such as intelligent tutoring systems or adaptive or personalized learning systems. Khan Academy's Khanmigo is an example of such an AI system. The second category is teacher-facing, in which AI systems are used to support the teacher and reduce their workload by automating tasks such as administration, assessment, feedback, and plagiarism detection. Turnitin's plagiarism detector is an example of a widely used teacher-facing AI system in schools. The third category is system-facing, where AI systems provide information for administrators at the organization level, for example, to monitor student attendance or discipline and provide student risk analyses. PowerSchool's Unified Insights program is an example of a system-facing AI technology. Globally, the educational community is committed to better understanding AI systems and their uses in education. The United States Department of Education released a report called AI and the Future of Teaching and Learning in May 2023. The report provided some key insights that highlight the potential utility of AI in education. AI may be able to enable new forms of interaction. Students and teachers can speak, gesture, sketch, and use other natural human modes of communication to interact with computational resources and each other. AI can generate human-like responses as well. These new forms of action may provide supports to students with disabilities. AI may be able to support educators. Educators can be involved in designing AI-enabled tools to enable them to more effectively engage and support their students. AI may be able to help educators address variability in student learning. With AI, designers can anticipate and address the long tail of variations in how students can successfully learn, whereas traditional curricular resources were designed to teach to the middle and most common learning pathways. For example, AI-enabled educational technology may be deployed to adapt to each student's English language abilities with greater support for the range of skills and needs among English learners. AI may be able to support powerful forms of adaptivity. Conventional technologies adapt based on the correctness of student answers. AI enables adapting to a student's learning process as it unfolds step by step, not simply providing feedback on right or wrong answers. Specific adaptations may enable students to continue strong progress in a curriculum by working with their strengths and working around obstacles. AI may be able to enhance feedback loops. AI can increase the quality and quantity of feedback provided to students and teachers, as well as suggest resources to advance their teaching and learning. The key takeaway is that AI systems have the potential to support and augment teaching and learning as a valuable tool, as can be seen with current AI systems in education. As the conversations regarding AI in education continue, it is important that each local education agency begin a dialogue internally around the incorporation of AI systems into the classroom. This slide provides some high-level starter questions for local education agency leaders to consider for these conversations, some of which were adapted from questions created by the International Society for Technology and Education, also known as ISTE, in collaboration with the School Superintendents Association, or AASA. An open discussion with educational leaders, teachers, students, and other educational stakeholders, such as parents and guardians, about the purpose, possible considerations, and the professional learning that must occur for teachers and students before implementation is necessary to drive the adoption of specific AI systems in the classroom. Alongside organization-level conversations around AI, classroom educators should also consider key questions when evaluating the use of AI systems in their classrooms. This slide notes some of these high-level questions intended to provoke thought and facilitate dialogue about how these tools are best implemented. The New Jersey Department of Education is excited to release an artificial intelligence webpage that provides additional resources for educational stakeholders. This webpage provides an overview of AI, similar to the information on the webinar, and provides resources to learn more about AI, resources for educators to teach their students about AI, as well as links to further research and reports regarding AI. The webpage, which can be found under the Office of Innovation's main page, will be updated regularly to keep up with the fast-paced changes to AI in the education space. So, what are the next steps being taken by the department regarding AI in education? The New Jersey Department of Education is participating in the Teach AI initiative, a partnership to develop a framework for teaching about and with AI. The partnership is led by Code.org, Educational Testing Service, the International Society for Technology, Khan Academy, and the World Economic Forum. The goal of Teach AI is to guide governments and educational leaders in aligning education with the needs of an increasingly AI-driven world and connecting the discussion of teaching with AI to teaching about AI and computer science. This new effort will convene technology leaders such as Amazon, Cisco, Microsoft, and OpenAI, education organizations such as a Superintendents Association, College Board, Council of Chief State School Officers, National Association of State Boards of Education, National School Boards Association, leading university researchers and equity-focused groups such as Black in AI and National Center for Women and Information Technology, numerous state departments of education, as well as education ministries and associations from around the world. Additionally, guided by the work of Teach AI and through engaging in national conversations and discussions with experts, the NJDOE plans to create and disseminate supports to the field with timely updates as AI is continually evolving. Thank you for viewing this technical assistance webinar regarding considerations for AI and education. We hope you found the information helpful and have an idea of what discussions are needed within your educational community. The department will put out guidance and resources on its artificial intelligence webpage with updates as the field of AI continues to evolve. Please email innovation@doe.nj.gov with any questions you may have regarding this webinar or the information on the artificial intelligence webpage. Thank you.